Hello students, welcome to the course Network Theory. In the previous video, I explained you the statement and proof of the Thevenin's theorem. Okay, so hope you have understood. So if you have any doubts, you can ask me. Fine. So also we have discussed the action plan. So if the problem is given, so what is the steps we have to follow, and the different steps to compute the RTH also I told you. And separately I will solve the examples also I mentioned. Okay. So just recall. So the four action plans, the first one is if any circuit is given along with circuit B. Okay. If it is given, some cases they will not give the load, just the open circuit only they will give and tell you to find out the Thevenin's equivalent circuit. Okay. In case if they ask some current or voltage in the circuit, then definitely there is a closed circuit. Maybe a resistor will be there as a load. In that case, you have to divide the original circuit into circuit A and circuit B. You have to separate it. Okay. And then you have to separate the circuit A from circuit B. That is the step. And then replace circuit A with its Thevenin's equivalent. That is ETH in series with RTH. So Thevenin's voltage source, Thevenin's equivalent resistance. Okay. And then finally, if you have to compute any current or voltage, you have to reconnect the circuit B and apply the KVL and find out the variable of your interest. Okay. Then there are three methods I mentioned, procedure for finding RTH. So the first procedure I will try to explain here with an example or problems. Okay. So the first one, what is that resistance? If you have independent sources only independent sources, there is no dependent sources and resistors, then you have to deactivate the sources and find RTH by circuit reduction techniques. What we have done in proof. Okay, the same one example I will consider here with just values of R1, R2, R3, so that you will understand it better. Okay, and then we'll take another example. The circuit is already opened. Okay, so both examples we will try to see in this video. For all the circuits, this is the final Thevenin's equivalent circuit you will have. So note down this first problem on Thevenin's theorem. So question will be asked using the Thevenin's theorem. Previously you have seen using superposition theorem, using Millman's theorem. Okay, so that's why concept should be clear to you what is meant by the particular theorem. Okay, so using the Thevenin's theorem, find the current I through R equal to 2 ohm resistor. Okay, for the circuit shown in figure. So this 2 ohm here maybe missed out in this one. 2 ohm. That means what? This is now circuit B. Okay, so R is given. So note down this same question I have given in the proof. I have used this, right? E I have used E value I have given 50 now, and this was R1, R2, R3. R1 is 5 ohm, R2 is 4 ohm, R3 is 20 ohm I have given, and the load RL is given 2 ohm. Okay, the same circuit is given so that you can relate it with the proof. Okay, so that's why. So now hope you have noted down this question. So now to solve the action plan we have to apply. So first we'll separate the circuit B for the time being. Okay, so then you will have only the circuit A. So then you find the Thevenin's equivalent voltage VTH and the RTH and write the equivalent circuit, and then finally reconnect this load and find the current I. Okay, that is what they have asked, right? So this is what our final interest. To do this, there are many methods are there. Okay, so you can go with normal mesh analysis also, you can solve node analysis also, you can solve it, but that is not the question here. It is the applying of Thevenin's theorem, application of Thevenin's theorem, we need to do it in this problem. Okay, so that's why at a very beginning only I mentioned. So network, every network looks like almost similar, little bit changes here and there with the values and orientation, but the methods, different methods you are going to learn in this Thevenin's network theory. Okay, that is the interesting one. Okay, so we'll try to solve this problem now. Okay, as per action plan, so we identify R equal to 2M as the circuit B. So identification also important. Sometimes it is not going to give in right side only. It may be somewhere in upside or somewhere it is. Okay, so you have to identify first where you have to divide, and then left of the AB terminals as circuit A. We have identified circuit A and B and we have separated it. Okay, so now our aim is to find the Thevenin's equivalent circuit at the terminals AB of the circuit A. So what you have now here is 5 ohm, 4 ohm and 20 ohm, 50 volt. Just you have the proof with you. If you have written the notebook, just you can recall that pages and see here. You had the same thing there, finding ETH. We have written ETH. Okay. So this is the same circuit we have written R1, R2, R3, E, and this is opened, right? But when we don't have the values, the proof becomes lengthy, right? Because we have to discuss in terms of R1, R2, R3, I2, then we have rearranged it, everything. Fine. Now values are there, so straight away we will get the answers by applying the KVL. Okay, so this is the open circuit voltage. It is also called as the Thevenin equivalent voltage. Nothing but what you have to find out the voltage across 20 ohm resistor. Nothing but you need to have the current, how much it is flowing, because voltage is nothing but current into voltage. So you need to find the current in this branch. If you know the current in this branch, you can find the VTH. Anyhow, there is no current here because it is open. So it is current is 0 and it is 0 volt will flow. So this is not going to play any picture. So now you have 50 volt and 5 ohm and 20 ohm. So just you can apply the KVL also, you can apply and find the current I, or you can do the straight away VDR you can apply for VTH. It is a very simple one, right? So that also you can do here. So see, it is your choice now again. Okay, so beginning step is Thevenin's theorem, but next what you have to use based on your choice. So which one you are familiar with. Okay, so I have applied KVL here. So since mesh analysis, okay, even you can apply the uh, this one, okay, the VDR. So apply KVL to the loop on the left of the above circuit. So you will have 50 minus 2 plus 50, then drop, okay, minus 5i minus 20i equal to 0. So in case if you write with notation minus plus, minus is first symbol, so minus 50 plus 5i plus 20i it will come. Both equations are same. Okay, so minus 20 minus 5 minus 25. So I have taken it right side and rearranged it. So you got 25 equal to 50. So I equal to 50 by 2 is 50 by 25 equal to 2 amps. So I you got, so now you can find the VAB or VAOC, or it is also called as Thevenin's equivalent voltage VTH, which is 20 into I as I mentioned. So it is 20 into 2 equal to 40 volt. Clear? Fine. So I to mention we can use Thevenin's VDR also. So if you apply VDR here, what will happen? Just you look at, so voltage is then 50 volt, right? So VDR, so total voltage is 50. Across which resistor you have to find? 20 ohm divided by total resistance, that is 20 plus 5. Okay, so straight away you can do also. Okay, whichever is convenient you can do. I have shown you here KVL. Okay, so it is 25 2 times the 50, so 2 into 20 is 40 volt. See here, answer will come same. You can use any rules, whichever. So here it is a simple circuit, you can go for anything. Okay, so we got 40 volt, same answer. So answer will not come wrong, any rules you can use. Fine. So one first part is over, that is finding the VTH. Okay, next RTH we will find. Okay, see, when you have to apply VDR also you should be careful. Okay, it is not always. So when you have number of resistors connected in series only it is applicable. If there is parallel, it will not apply. Parallel is there, current divider rule will come. Okay, so series circuit only. Okay, 2 or 3 elements, no, only for 2 elements. 3 elements also you can do that, but little bit complex will come. That's why you use always go for node analysis, mesh analysis. Okay, so that's why I've used that same only, so that you should not confuse. But if you know where to apply VDR, so then you can do it in quick manner. Okay, fine. So now to find RTH, what we have to do? So very first step, we have observed that there is only independent source and resistors. That's why we have taken this step. Okay, so we have to deactivate the independent source. That is the first step I told you, right? Even in the derivation we have done the same way. Okay, so we got 5 ohm, 4 ohm and 20 ohm. So we need to find the equivalent resistance at the terminals AB. So if you look at the orientation now, so 5 ohm and 20 ohm are in parallel, and this parallel resistor is in series with 4 ohm. That's why, so in single line, so this RTH is written 5 ohm in parallel with 20, and in series means plus. So parallel we need to compute for two resistors, R1 R2 by R1 plus R2 is the formula. So 5 into 20 by 5 plus 20 plus 4. So how much it will give? 100 by 25 means 4. 4 plus 4, it is 8. Okay, so RTH you got is 8 ohm. Okay, no need of calculator also. Simple oral mathematics you can do the simplification. Okay, if such type of problems are there. Okay, so you got now VTH, and the first type of finding RTH also I mentioned with this example. Okay, that is our intention here, to show you methods application. Okay, so next what you have to do, you have to draw a Thevenin's equivalent circuit. Some cases they will tell you, right, Thevenin's theorem. So first Thevenin's equivalent circuit you will write. So what is Thevenin's equivalent circuit? VTH, that is 40 volt in series with RTH, which is 8 ohm. Okay, so this is the Thevenin's equivalent circuit. So now what you have to do, last time you have to connect the circuit B, which is the load resistor RL is 2 ohm, and then you have to find out the apply the KVL and you have to find the current. Okay, reconnect circuit B to the Thevenin equivalent circuit as shown in figure below. Okay, so see here, this is the Thevenin equivalent circuit at the left side of AB, and right side I have the load now 2 ohm. Okay, so now you apply the KVL, so you'll get the current I, that is what required in the problem, right? So applying KVL here, so minus to plus I have taken 40 plus 40. This is drop, so minus 8i and this minus 2i equal to 0. Even you can write, if you are writing with minus sign is beginning, so you can write minus 40, and current always enters through the plus terminal in resistor. Okay, because it is absorbing element. Okay, plus minus, so it is plus 8i plus 2i, it will come equal to 0. Same answer will come. Okay, so 10i equal to 40 you will get, and I is equal to 40 by 10 is equal to 4 amps. So finally you write current in R equal to 2 ohm is 4 amps. That is the answer. Okay, and remember, if they give the values of resistors in kilo ohm, don't forget to write the current in milliamps. So you write the numbers as it is, but writing current you write it in milliamps. Voltage it does not vary, so it will be in volt only. Okay, so this is the first problem on Thevenin's theorem. I feel it is easy for you, right? You felt easy compared to the previous one. Okay, that is what the application of this theorem. So circuit will be uh, reduced in different manner. Okay, so if you have to apply here mesh analysis, the equations, three equations you have to write, solve it. Okay, plenty of issues will come, right? Fine, so this is one simple circuit. Okay, the application you have to understand how to apply it, that is important. That's why big circuits we are not analyzing it, and they are not asking in exam also. Okay, because time is required. No, within that much time you have to learn many concepts, right? Still we are in second module, third module, fourth module, fifth module, still many concepts are there, many problems they have to cover up. That's fine, they will not take, because if big problem is taken, so more time we should specify. Okay, so it is not possible. Fine, so we'll see another problem based on this. Okay, the same method. Find V naught in the circuit of figure using Thevenin's theorem. So we need to find V naught now across 2 kilo ohm resistor. There is no resistors connected here. Connected, oh yes, connected, right? So this is the load now across V naught, means this is the circuit B. Okay, which is connected from this node to this node. This should be considered as circuit B. Okay, previous case they have asked the current in this branch, right? Current in R equal to 2 ohm. So now they have asked, we need to find the current in this branch. Okay, and then you have to multiply with 2 kilo ohm, you will get the voltage V naught. One step more. Okay, and what we have done is we have given one additional current source here and voltage sources, so all are independent. So that's why we can go for first method, so no issues, same as first one we can carry on. Okay, so hope you have noted down this question. So we'll try to solve this now. Very simple. Okay, okay, so first step is to find the VTH, right? So we have separated the circuit A, that is the first step. Since we are interested in the voltage across 2 kilo ohm resistor, it is treated as circuit B and is removed from the circuit of figure. This is the first step. Okay, step 1. And then the remaining part of the original circuit is as shown in figure. So you have to redraw the circuit as circuit A. So now you have to find the VTH. So this should be come here. Okay, after writing this circuit, this step should come here. Okay, fine. So now how to find out? So you need to find out VTH, means you require the KVL you have to apply here. Anyhow, you require the current in this resistor and also the current in this resistor, right? So then these two we can add, you will get the VTH. Applying the KVL at this outer loop, you will get that. For that you require the currents here. That's why I will call this as I1 and call this as I2, and I will apply the KVL. Okay, Kirchhoff's voltage law, and we will find out. Okay, since current is asked straight away, we can go for mesh. If they have asked any node voltages here, we can go for nodal analysis. Okay, fine. So now what we'll do, so here current source is in the outer branch, that's why it is not a super mesh. So this I1 current straight away we can relate it to this amps. Okay, so I1 no need to find out, I1 equal to 4 milliamps. Okay, then we have to write the KVL for this. It is 12 minus 6 I2 minus I1, 3 I2 equal to 0, where I1 is there, you substitute this 4 milliamp value, and find out the new value of current I2. Then apply the KVL in this branch. So you'll get 3 kilo ohm into I2 and 4 kilo ohm into I1, and that will be VTH. Okay. Hope you have understood what I am explaining. So we'll solve that. Okay. So note down this, all the equations and steps. I will go further. You pause and note down. So from by inspection, I1 equal to 4 milliamps. So hope you, if you have gone through mesh analysis, we have done such problems also. If current source is in the outer loop, we'll relate it to that. So it is in the direction of the I1, that's why 4. If it is opposite to that, minus 4 we would have considered. Okay. So next, apply the KVL to mesh 2. So no need to write this 10 to the power 3 as I mentioned. So while writing current, finally you have to write in milliamps. Okay, that's only you should keep in mind. So that's why it is 12 minus 6 into I2 minus I1 minus 3 into I2 equal to 0. Okay. So when you simplify this, 12 equal to, it is 6 into I2, then minus of this one. So minus of what they have done, minus of minus plus, no here. Okay, I have taken right side, that's why. Okay, so 6 into 10 to the power 3 I2. So here it was coming plus, but I have taken right side. This current I have taken right side, that's why it is minus. Okay, this minus, it became plus here. See here it became plus. Minus was there, but I have taken right side, that's why equal to came now, that's why plus. And here plus would come, but it is minus now. And I1 I have substituted 4 milliamps. Okay, so kilo milli cancel out here, and here 3 into 10 for the 3 I2. So now you have got everything in terms of I2. You solve this value, 6 into 4, 24, minus 24 will come. I have skipped many steps so that you will understand. Okay, 6 into 4, 24. This minus I have taken left side again, so 12 plus 24 it comes. And here 6 is there, here 3 is there, so 9 I2. Okay, 9 I2 equal to 36. So I2 is equal to 36 by 9. You can write, it is will be in kilo ohms, so that will be 4 milliamps. So if you remember that kilo, you have to substitute milliamps. Okay, otherwise follow this method only, 10 to the power 3 writing. Okay, so that anyhow in the problem it will show you, right? Fine. So this is how we will find the mesh current I2, first step. Okay, now we'll find the VTH from this calculation, I1 and I2. So you'll apply the KVL to the path, that is the path 4 kilo ohm A, B, and the 3 kilo ohm. Okay, so that is the outer loop we will apply. So minus is there, so minus 4 into 10 to the power 3 I1 plus VTH. So now plus VTH because we have taken reverse. Okay, just if I show you, okay, this is the circuit, right? I have applied the KVL in this manner. Okay, anti-clockwise I have taken, so that's why it is minus plus is there. No, sorry, I have taken this way only, that's why minus, sorry. So I have taken like this only. Okay, fine. This is I2 is there, plus minus, and here it is plus minus. Sorry, current is like this manner, no? So that's why it is plus minus here. Okay, so that's why here you will have plus 3 into I2 minus 4 into I1, and it is plus 2 minus is there. Okay, that's why minus VTH equal to 0. So minus 4 into 10 to the power 3 I1. Okay, so plus VTH minus 3 into 10 to the power 3 I2 equal to 0. So resistors we have considered in that manner. Okay, no issues. Because here I have taken new current value, no? That's why. Okay, so don't confuse with the other loop. With respect to this loop, current how it is entering, that side we will take plus. Okay, fine. VTH equal to 4 into 10 to the power 3 I1 plus 3 into 10 to the power 3 I2. So you'll get, it is 416 kilo milli cancel out. Here also kilo milli cancel out. 3 into 4 12. 16 plus 12 is 28. So you get 28 volt as the VTH value or VAB value or open circuit VOC value. Okay, so this is the first part. Fine. So same as previous, no changes. So next one, you have to find RTH. So both we have independent sources, so we'll deactivate that. So current source we will open it, so then upper loop will go away, right? Upper branch will go away because open circuit, and current source is short circuited here. So it looks like same as the previous circuit, right? 6 kilo ohm, 4 kilo ohm, and 3 kilo ohm. Okay, so again if you look at the circuit, 6 and k 6 and 3 are in parallel, which is in series with 4 kilo ohm. Okay, so that's what written, 4 kilo ohm plus 6 kilo ohm in parallel with 3 kilo ohm. So 4 plus 6 into 3 divided by 6 plus 3. So you will have 18 by 9, 2. 2 plus 4 is 6 and it is kilo ohm, right? So that's why 6 kilo ohm is the RTH value. So now you replace the original circuit with equivalent, Thevenin's equivalent circuit, where ETH in series with RTH. So that's what written. Okay, so plus minus 28 volt into 6 kilo ohm, 28 volt 6 kilo ohm. Clear? So now what you have to do, you have to connect the 2 kilo ohm which is removed here. You have to apply the KVL, you will get current I, and that current I you have to multiply with 2 kilo ohm, you will get the asked voltage. Okay, first problem you have seen current, second problem you have seen voltage, so that both variety will be understood to you. Okay, so if we connect the 2 kilo ohm resistor to this equivalent network, we obtain the circuit of figure below. So this is what we need to find out, V naught across this terminal, right? So just wire is extended here, okay, for showing this V naught, otherwise just calculating here. So first we find out I, applying KVL here. So 28 minus 6i plus 6i minus 2i equal to 0. So it is 8ki is equal to 28. So k also you can write kilo ohm, no, you can write like that, no issues. I equal to 28 by 8k or 10 to the power 3 you can substitute. So what you will get here, I have not computed, straight away I have brought it here. Okay, so I as it is I have written because interested in V naught. So V naught is 2k into I. So 2 into 2k into 28 by 8k. So k cancel out, 2 4s are 8. So 4 7s are 28. So that's why it is 7 volt. So the what is the value? V naught is equal to 7 volt. Okay, so this is the final answer. Hope you have understood this. So maybe first time I told you always, right, repeatedly saying. So everything you are learning here, new things day by day. Okay, so that's why it is a first time, you will not adjust to that. So you go through once again or write it once again, or write the circuit and do it by yourselves, let it be mistake. So then doubts will be cleared. I will tell you that is the best method to learn network theory. Okay, in case if you have doubts, as I mentioned, so note down in some notebook, okay, or mark it with pencils, and weekly once visit the college and meet me and clarify the doubts. Okay, because as we proceed with the, since online classes will continue as per government rules. Okay, we don't know when it will exactly begin, so we'll continue with this classes. So as we proceed with the module, so previous doubts if kept there, so you will not understand the next topic. Okay, so I suggest you can come anytime. Okay, that is not problem. Okay, sitting in classes together, that is problem is there, but coming and meeting and going, it is not a issue. Okay, so you can come and do that. Okay, fine. So with this we'll end the session here. So tomorrow we'll see the dependent sources and the two other methods are there, no, finding RTH. So that part of the question I will take up. Okay, so go through these two problems. Okay, and we'll see in the next video. Thank you.